Another great thing about QGIS is that we can work with raster data. Now, again, this is another one of those topics where there could be an entire course just in working with raster data. So my objective for this lecture is not to teach you all about raster data, but rather to show you how we can gain access to the raster tools within QGIS and begin to work with it. Later on, we're going to work on some real-world practical things with raster where we tie all this together. So the first thing I'm going to do is go in the C Training Tompkins Raster folder, and I've got a bunch of digital elevation models that I've obtained from the Cornell University Geospatial Repository site. And I'm just going to drag them in, and you can see now we have 6 different rasters. I can turn them on and off. So they're separate raster data sets. And again, they're single band rasters. We can change them to different colors as well. So we'll just leave this off for now. Actually, rather than moving on, let's just go over this. Here we're looking at a single band. We have a gray band. It's going from black to white for the color gradient. So white would be higher. You can see sort of the tops of the hills here. We can change this to a multi-band color. So there's different bands. Now in this case, we only have one band, so it doesn't make much sense but for something like a Landsat image, that would be a good idea. Here's an example. Let's move down to a hillshade. So when we come in here, we can start to see what a hillshade might look like. And you can see that looks a little bit, like the way the land would look depending upon where the sun angle is. So we can change the azimuth of the sun as well. And we can also change the altitude of the sun. And you can see that changes it quite a bit based upon the altitude. Let's lower that a little. Okay, so again, we can change the different parts of where the sun is coming from. Let's do it from, say, 24 degrees. Hit apply. All right, so you can see we got different sun angles occurring within our layer. Rather than doing a hillshade too, we can look at paletted colors. So again, either random colors or you can look at blues, something of that nature, and hit apply. All right, so we have a different color. So lots of different options that are available to us for performing our rendering. So let's hit cancel. So the first thing I might want to do, let's turn this on, is start to look at some of the things that we can do with rasters in general. You're going to find those capabilities under the raster menu item. Well, probably the first thing we want to do, I've got 6 separate rasters, so let's just look under miscellaneous and let's merge these rasters together. So who are going to be our input layers? Let's get all of them, right? Or we can clear the selection, but let's select all of them, hit OK, and that's it. We can now process these, and we'll let this run. Notice it's using a GDAL command. Now we have another course in using GDAL and programming with GDAL. This is a great way to learn GDAL because this is telling you the actual command structure to perform the merge. This is GDAL _ merge, and then there's a lot of other different types of command prompts that you put through. So let's close this. So now we have one complete raster where we had 6. We now have 1. So this enables us to now do some more things. Let's again look up into the raster. Let's just camp out in the miscellaneous again. One of the things we can do is build overviews or pyramids. So if you have really dense or really high resolution imagery, we can create a pyramid that will allow the raster to display a lot faster when we're zoomed out. Let's move next to conversion. So here we can polygonize a raster, so raster to vector, or you can rasterize. So a number of different functions here. We can go to extraction, so it can clip raster by an extent or by a mask layer. Why don't we do that? Let me go in and we'll grab another layer. So here I'm in the Training Tompkins and shape files. Let's grab the watersheds. We were looking at them earlier. And here you can see the different watersheds. Why don't we go in here and select 6 Mile Creek. So here's 6 Mile Creek watershed, and what I want to do is extract out the raster information for 6 Mile Creek. So under extraction, let's clip the raster by a mask layer. So the input layer is going to be the merged. The mask layer is watersheds, but let's use the selected features in this case. We actually didn't have to. We could have used the whole thing, but this is going to look a little more interesting as we do this. We've got information about what our source and target coordinate reference system is. We're not going to worry about that in this case, but that's also nice that when we're done, we can have something in latitude and longitude or state plane or something else. So let's just hit this and we'll run. And again, you can see we're using GDAL warp. So that's another command that's used from GDAL. So that's creating a TIFF. So like I said earlier, this is a great way to learn GDAL commands. Just run them through QGIS, and then you can eventually write it inside of GDAL. All right, let's turn the rest of these things off for a moment. And let's turn our clipped mask on, turn the merged off. There we go. So this is a masked version of the 6 Mile Creek area. Come in here, let's turn this off again, use our merged, turn that on. So now I can also go to extraction and I can extract it by the extent. So we'll use merge. So what do I want the clipping extent to be? I can put in a series of coordinates or have the option to use the canvas extent or select the extent on the canvas. How about here? Okay, that's good. Let's run it. That's done, and now you can see we've extracted out just that area that we looked at before. There it is. So with this one, let's go back to the extraction again, and let's make some contours. So again, QGIS has, using the GDAL commands, a lot of good raster functionality. We can create 10-foot contour intervals, and based on the elevation value, let's run that. And that's finished. And here are our contours. So these are the contour lines that are created. You can see where a channel is in place. So this is again, a really powerful tool inside of QGIS to create contours. All right, let's move to another menu. Here I'm going to go to the raster conversion. And why don't we go from raster to vector? So this is a classic type of a test, and vector to raster. So let's start off with vector to raster. I've got a new frame here with my watersheds in place. So what I'm going to do again is raster, conversion, and vector to raster. So I'm going to use the watershed Tompkins. It has a field in there called watersheds. It's an individual unique number. So we'll use that. We can also use the georeference units. And I'm going to make this 100-meter grid cell size. It's a bit large, but just for the video, this is going to be nice to be able to run it in sort of in real time. Also for the output extent, rather than using the whole map, I'm going to select the extent on the canvas. So let's go from here over to here. That's probably good enough. So we have our extent, and we have our raster size. And what you also see too is you've got your GDAL rasterize command already established for us here. So let's run this. And that's done. And if I close this box, you can see I now have actual rasters. These are no longer polygons. They're rasterized pixels that represent the data from the watersheds. So one of the things we can do is I'm going to select the rasterized, and I've got my info button. Click, that's band. That band number is 12. This is 11. That was that watershed number. So if we click here, you can see here's watershed 12. And this is watershed 11. That's 6 Mile Creek. So again, you can see that we're looking at an actual raster version of the data that was derived from the vector data. Let's go back the other way. So why don't we go to raster conversion and let's polygonize it. So which one do we want to take? Let's look at rasterized. We'll use the band number, and here's again the command. Let's run that. That's done. And now we have a vector version of that. Let's turn this off. So this is called vectorized. And of course it's going to have a digital number or a value associated with it. And sure enough, here's our digital number. And there we go. So in looking at this, you can see sort of what this looks like when it's gone from raster to vector back to vector. So it's not quite exact, and that's because we're looking at the center of the cells as we go through the rasterization and the vectorization process. So at this point, we've gone through the conversion process, looked at a few things. We've gone through some extraction, actually, from each of these. We've also done some of the miscellaneous things like merging the data. We can also assign a projection or extract a projection or warp and reproject the data. So we can take the merged data, and we have our source already, and we can make our target latitude and longitude, and it will use a different resampling technique. Is there another one I want to use? No, yeah, let's move it to UTM zone 18, because that's planar. So again, there's a number of different ways within the algorithm: bilinear interpolation, cubic, nearest neighbor. So in our case, we're going to use nearest neighbor. And again, if you're taking a full GIS class, there's reasons why you would use nearest neighbor versus a bilinear stretching or cubic stretching of the data. So we'll just go with nearest neighbor at the moment, which is going to preserve the numbers versus changing the actual numbers. So let's run this. And with this now completed, let's take a look at it. I'm going to right click on reprojected, and we'll zoom to the layer. And it doesn't look much different, but you'll notice if I turn this off, it is the raster data now in the UTM coordinate system. And in this case, we'll take the merged layer, and we've got its source, but we're going to project it. Yeah, why not? Let's project it to latitude and longitude, and we'll use the nearest neighbor method for resampling. Now, there's a whole bunch of different methods, and if you took a course in GIS, you'd learn the difference between, say, using a bilinear interpolation versus nearest neighbor. Now, we'll use nearest neighbor. That's going to preserve the data values rather than interpolating them. But let's just run this, and that's completed. And as we look at this, you can see this is now a little bit stretched out looking because it is in latitude and longitude. So here is our original merged. Here is the reprojected value. And again, if I look at this merged and we get the properties for it, you can see this is in UTM zone 18. But the reprojected, if we go to the properties, is in latitude and longitude. So this might be a case where you want to get all your rasters into the same coordinate system. You can begin to perform the warping. Well, I think that's about all we'll do for now in this lecture, because we're going to move on to two really big pieces of raster analysis within QGIS, and that's the raster calculator and the raster analysis capabilities. Those are big ticket items. They're going to take a bit of time for us to work through. So what I want to be able to do is devote an entire lecture to that. So we'll see you on the other side.